Implementing Industry 4.0, the role of automated quality management. In today's rapidly evolving industrial landscape, the emergence of Industry 4.0 has revolutionized manufacturing processes, paving the way for a new era of intelligent and interconnected production systems. At the heart of this transformation lies the integration of advanced technologies, data-driven decision-making, and automation to create what is known as smart manufacturing. As companies strive to stay competitive and meet ever-increasing customer demands, the focus on quality management has become paramount. To ensure superior product quality and streamline operations, manufacturers are now turning to automated quality management (AQM) systems, a key enabler in their journey towards Industry 4.0. In this article, we explore the crucial role of automated quality management within the context of smart manufacturing. The term Industry 4.0 refers to the fourth industrial revolution, characterized by the integration of digital technologies into manufacturing processes to create smart and interconnected factories. It encompasses a wide range of advanced technologies and concepts that are reshaping the manufacturing landscape. Industry 4.0 leverages automation, data exchange, and real-time analytics to enable smarter and more efficient production systems. Furthermore, automated quality management plays a crucial role in successfully implementing Industry 4.0 principles in manufacturing. As production processes become increasingly complex and interconnected, the challenge of maintaining high-quality standards throughout the entire manufacturing lifecycle intensifies. AQM systems actively enable manufacturers to monitor and control quality parameters in real time, guaranteeing that products meet stringent quality requirements. By leveraging advanced technologies such as IoT, data analytics, and artificial intelligence, AQM not only enhances quality control practices but also drives continuous improvement, ultimately contributing to the success of smart manufacturing initiatives. One of the key elements of Industry 4.0 is the Internet of Things, IoT, and connectivity. By actively enabling the interconnection of various devices, sensors, and systems within the manufacturing environment, IoT plays a vital role in facilitating seamless data exchange. This connectivity further enables real-time monitoring of production processes and quality parameters. IoT devices actively collect and transmit data, offering valuable insights into the performance, condition, and quality of machines and products. By integrating automated quality management with IoT, manufacturers can achieve enhanced visibility, control, and optimization of quality-related processes. Cyber-physical systems, CPS, are an essential component of Industry 4.0. CPS combines physical machinery and equipment with digital technologies, allowing the physical and virtual worlds to interact seamlessly. In the context of automated quality management, CPS enables the integration of quality control systems with the production infrastructure. Real-time data from sensors, machines, and production lines are collected, analyzed, and used to make informed decisions and take immediate action to ensure product quality. By leveraging CPS, manufacturers can achieve tighter integration between quality management processes and the physical manufacturing environment. Industry 4.0 leverages cloud computing and big data analytics to handle the massive amounts of data generated within smart manufacturing environments. Cloud computing provides scalable storage and computing capabilities, enabling manufacturers to store and process large volumes of quality-related data. Additionally, big data analytics techniques are then applied to extract meaningful insights from this data, uncovering patterns, trends, and correlations related to product quality. By analyzing historical and real-time quality data, manufacturers can identify potential quality issues, optimize processes, and implement preventive measures to ensure consistent product quality. Artificial intelligence, AI, and machine learning, ML, technologies play a transformative role in Industry 4.0, including automated quality management. AI and ML algorithms can analyze vast amounts of quality data, identify patterns, and make predictions regarding product quality and process performance. These technologies enable manufacturers to move beyond reactive quality control towards predictive and prescriptive quality management. By continuously learning from quality data, AI-powered systems can provide valuable insights, optimize quality control processes, and even autonomously make decisions and adjustments to ensure optimal product quality. Automated quality management systems enable real-time monitoring and control of quality parameters throughout the manufacturing process. Traditional quality control methods often rely on periodic sampling and testing, which may result in delayed detection of quality issues. But with automated systems, sensors, and data collection devices continuously monitor critical quality variables, providing immediate feedback on process performance and product quality. Real-time monitoring allows for proactive interventions and prompt corrective actions, minimizing the risk of producing defective products or non-compliance with quality standards. By ensuring quality control in real time, manufacturers can reduce waste, minimize rework, and improve overall production efficiency. Corrective and preventive action, CAPA, is a fundamental component of quality improvement strategies in manufacturing industries. CAPA is a systematic approach used to identify, investigate, and address the root causes of nonconformities or deviations from established quality standards. It aims to correct existing issues and prevent their recurrence, ensuring continuous improvement in product quality, process efficiency, and customer satisfaction. By implementing an effective CAPA system, organizations can proactively identify areas for improvement, mitigate risks, and foster a culture of continuous learning and innovation. CAPA serves as a powerful tool in driving quality improvement initiatives, enabling companies to stay ahead in today's competitive business landscape. Automated quality management systems generate vast amounts of data that can be leveraged for data-driven decision-making and continuous improvement. Through the application of advanced analytics techniques, such as statistical analysis and machine learning algorithms, manufacturers can gain valuable insights into the relationships between process parameters and product quality. By analyzing quality data, manufacturers can identify trends, root causes of defects, and areas for process optimization. These insights enable data-driven decision-making, allowing manufacturers to implement targeted improvements, optimize production processes, and enhance overall quality performance. The continuous improvement becomes a systematic and data-guided process, leading to enhanced product quality, customer satisfaction, and competitiveness. Automated quality management systems contribute to cost reduction and operational efficiency in smart manufacturing. By minimizing quality defects and ensuring compliance with quality standards, manufacturers can reduce scrap, rework, and warranty costs associated with poor quality products. Real-time monitoring and predictive analytics help optimize production processes, preventing quality issues and reducing the need for costly corrective actions. Additionally, automated systems also enable faster detection and resolution of quality deviations, minimizing production downtime and maximizing equipment utilization. Improved quality control and operational efficiency result in lower production costs, improved resource utilization, and increased overall profitability. To support automated quality management systems, a robust and reliable network infrastructure is essential. High-speed connectivity allows for real-time data transmission and seamless integration of quality data with other manufacturing systems. This connectivity enables continuous monitoring, data analysis, and decision-making in real time. Manufacturers need to invest in a secure and scalable network infrastructure that can handle the increasing volume of data generated by AQM systems. Selecting the appropriate software and tools is crucial for the successful implementation of automated quality management systems. Manufacturers should consider software solutions that offer features such as real-time data visualization, data analytics, and predictive modeling capabilities. The software should be compatible with existing manufacturing systems and able to integrate seamlessly with data from various sources. The software should provide open API so that the same can be integrated with any system as required. Implementing automated quality management systems requires a skilled and knowledgeable workforce. Manufacturers need to invest in training and upskilling their employees to effectively operate and manage these advanced systems. Training programs should focus on understanding the principles of AQM, data analysis, and system operation. Employees should be familiar with the use of software tools, interpreting quality data, and implementing corrective actions based on real-time insights. Upskilling the workforce ensures that they can leverage the capabilities of AQM systems to drive continuous improvement, enhance product quality, and maximize operational efficiency. Implementing automated quality management systems brings concerns about data security and privacy. With the collection and analysis of vast amounts of quality data, it becomes crucial to ensure that data is protected from unauthorized access, breaches, or misuse. But manufacturers must establish robust data security measures, including encryption, access controls, and secure data storage. Additionally, compliance with relevant data protection regulations, such as the General Data Protection Regulation, GDPR, is essential to safeguard customer and sensitive manufacturing data. Integrating automated quality management systems with existing manufacturing systems and infrastructure can pose challenges. Compatibility issues, data interoperability, and connectivity between different systems need to be addressed. Hence, manufacturers should evaluate their current systems and infrastructure to identify any gaps or limitations that may hinder the successful implementation of automated quality management. Seamless integration ensures the smooth flow of data, real-time insights, and effective coordination among different components of the manufacturing process. Implementing automated quality management systems often requires changes in processes, roles, and responsibilities, which can be met with resistance from employees. Therefore, some may be hesitant to adopt new technologies or fear that automation will replace their jobs. To overcome resistance, manufacturers need to foster a culture of openness, communication, and collaboration. Providing training and clear explanations of the benefits of AQM can help employees understand the positive impact it can have on their work and the overall organization. Examining real-world examples of companies that have successfully implemented automated quality management systems in smart manufacturing can provide valuable insights. Case studies can showcase different industries, such as automotive, electronics, or pharmaceuticals, and how they have leveraged automation to improve quality control. These examples can demonstrate the diverse applications of AQM and inspire other manufacturers to adopt similar approaches. Case studies should highlight the benefits and outcomes achieved through the implementation of automated quality management systems. This can include improvements in product quality, reduced defect rates, increased operational efficiency, cost savings, and enhanced customer satisfaction. Quantifiable metrics and success indicators should be presented to showcase the tangible results obtained by implementing such a system. Sharing lessons learned and best practices from successful implementations can guide other manufacturers in their journey toward automated quality management. Case studies should highlight the challenges faced, solutions implemented, and lessons learned throughout the process. This helps manufacturers understand the potential pitfalls, effective strategies, and key considerations for a successful implementation. By sharing best practices, the industry as a whole can benefit from the collective experiences of companies that have embraced AQM in smart manufacturing. The field of automated quality management is constantly evolving, driven by advancements in technology. Emerging technologies such as blockchain, augmented reality, AR, and edge computing are expected to play a significant role in the future of quality management. Blockchain technology can enhance transparency and traceability in supply chains, ensuring the integrity of quality data. AR can provide real-time guidance and visualizations for quality inspections and maintenance activities. Edge computing enables faster data processing and analysis, facilitating real-time decision-making for quality control. As Industry 4.0 progresses, the integration of automated quality management with other technologies will become increasingly important. Therefore, AQM systems will be seamlessly integrated with other Industry 4.0 technologies such as robotics, additive manufacturing, 3D printing, and digital twin simulations. This integration will enable real-time quality control and feedback loops, where data from quality inspections and process monitoring can be fed back into the manufacturing process to make immediate adjustments and improvements. The synergy between these technologies will drive continuous improvement and ensure consistently high-quality products. The future of automated quality management holds promising advancements and opportunities. Furthermore, advancements in artificial intelligence, AI, and machine learning will enable more sophisticated quality prediction models and anomaly detection algorithms. Therefore, predictive analytics will become more precise and accurate, providing manufacturers with actionable insights for quality improvement. Additionally, the use of robotics and autonomous systems for quality inspections and testing will become more prevalent, reducing human error and enhancing efficiency. Furthermore, the increasing adoption of cloud-based platforms and the Internet of Things, IoT, will enable seamless data sharing, collaboration, and benchmarking across manufacturing ecosystems. Automated quality management plays a vital role in smart manufacturing, enabling manufacturers to ensure consistent product quality, optimize processes, and meet customer expectations. By leveraging real-time monitoring, predictive analytics, and data-driven decision-making, these systems provide manufacturers with valuable insights into their production processes, enabling them to detect quality deviations early and take immediate corrective actions. The integration of AQM with other Industry 4.0 technologies creates a synergistic effect, facilitating continuous improvement and driving overall manufacturing excellence. The implementation of automated quality management systems brings numerous benefits to manufacturers and the industry as a whole. Manufacturers can achieve higher levels of product quality, reducing defects and rework while enhancing customer satisfaction. Hence, the ability to make data-driven decisions and optimize production processes based on quality data leads to improved operational efficiency and cost savings. Additionally, these systems contribute to regulatory compliance, traceability, and supply chain transparency. These benefits collectively result in a competitive advantage for manufacturers, enabling them to thrive in the digital age of smart manufacturing. Lastly, as the manufacturing industry continues to embrace Industry 4.0 principles, the importance of embracing automation for quality control becomes paramount. In an increasingly interconnected and data-driven manufacturing landscape, manual and traditional quality control methods become insufficient to meet the demands of speed, accuracy, and traceability. Automated quality management systems provide the necessary capabilities to leverage real-time data, advanced analytics, and predictive models to achieve superior quality control. Therefore, embracing automation for quality control ensures that manufacturers can remain competitive, deliver high-quality products, and adapt to the evolving needs of the Industry 4.0 era.